Hello, everyone. I'm Mr. Medeiros, and I'm here with Mr. Falcon right now. What we're going to be doing is presenting to you what goes on in engineering technology from grades 6 through 8. As you know, things have been a little bit different over the last couple of years. We've had a lot more online learning. Kids were home for quite a while because of COVID. So, what we did originally um, will be adjusted a little. Typically, we had certain things we did in grade sixth grade, seventh grade, and eighth grade. But because kids were home for such an extended period of time, a lot of the computer based programs were done up front ahead of time. So kids are actually ahead of schedule on the computer based programs, which were done online, and a little behind on the hands on learning. So the end result is going to be after they're done with their 3 years here with Mr. Falcon and myself, we will still have covered everything, but we just have to readjust things a little bit. So as I mentioned, computer-based learning was done last year. We still have more to do on that, but we really got into it a lot more last year because of the situation. So this year we're going to transition more into hands-on learning. The end result is going to be that by eighth grade, everything will have been covered. It's just going to be shifted a little bit. So what we want to do in the next so many minutes is talk about what I teach, Mr. Medeiros, and then also what Mr. Falcon teaches. And again, normally we had an agenda for sixth, seventh, and eighth grade. It's kind of shuffled around a little bit. So we're going to just give you an overview of what goes on in technology for the entire year, or actually the entire 3 years. And then from there, if you have any questions, we'll have a little question and answer session. So what I'm going to do right now is I'm going to turn this over to Mr. Falcon. He's going to talk for a little bit on what he covers, and then he'll give it back to me, and I can talk about what I'm going to cover.
Hello, my name is Mark Falcon, and I'm one of the 2 engineering and technology teachers at Somerset Middle School. Today, I'm going to be talking about computer science, or as some people refer to it, programming. I'm sure everyone will agree that programming, known as computer science, has become an integral part of almost every aspect of our life. From medical devices to electronics of all kinds, to anything online, video games, and on the list goes. Simply put, because it is such an integral part of our life, we have come up with a curriculum that provides every student the opportunity to learn about computer science. Now, one of the things that we always say is everyone's going to do something different in life, what they enjoy, what they truly want to be good at, but we want to be able to allow every student to at least be aware that computer science is a career alternative and it's a career path, and let them try it out. So we are starting off the whole concept of programming with Scratch, our code, and other things that people are familiar with. But we've been moving slowly but surely over to tinker.com. In each case, we are using what is called block programming. Basically, you drag blocks of code, pieces of code around, and interconnect them in different ways. Hence the name block programming. So then they learn the basics without having to worry about all the syntax, and everything works properly coding wise because they just have to connect it. So they're going to learn how to control motion, interactions, and other such things normally found in games. After that, we move on to a more interactive type programming with drones. So now they have to think about motion in a 3-dimensional space. Instead of just left and right and et cetera, they have to deal with up and down motion, and they also have to deal with their environment. Can't go slamming into walls and such. From there, we add another level of complexity, and that brings a lot more learning. We get into robotics. So before we just had motion, and the students got pretty good at it. They avoided the walls and the columns in the classrooms and the tables. But with robotics, you get that motion, but now you add sensors, so now you're aware of your surroundings. Now, while the robot is navigating in some space, it can use the sensors to, for example, detect color, distance, and maybe touch. So let's say you have a button that when you run into a wall, it tells you you've touched a wall and you can get away from it. And for those students who are real go-getters, we also have a gyro, which is like a gyroscope, and it allows students to control their robot, make very, very accurate turns by the degrees. So this really helps to tune the control and the movement of their robots. As you can see from this picture, there are two sensors on this robot. One of them is a color sensor, and it is detecting the difference between the black and the white line. And the one that's just above the wheel is a ultrasonic, and that's like a bat, and it's detecting distance. So we then end their programming learning with a big competition. It's the sumo wrestling competition, in which, like in sumo wrestling in the real world, two robots fight for superiority in the big ring and try to either push the other person out of the ring or try to flip the other person over, which now incorporates everything they've learned: structures, design process, manufacturing, but two very important extra details. First, dealing with an opponent. Up to this point in time, you kind of just coded and did your own thing. Now you have to worry about an opponent. And in my opinion, the most important and the biggest challenge, working in a team to come up with a common goal. Typically, there's a lot of excitement around the sumo wrestling, and as long as everyone follows the rules, any idea is a good idea as long as they can incorporate it and it works and they get to test it out, and they should have a lot of fun. That concludes our section on programming. Thank you very much.
Hello, everyone. Mr. Medeiros back with you again. What I'm going to do now in the next few minutes, and I know we're kind of short on time, so I'm just going to go through everything briefly, is go over what your children will be studying with me, Mr. Medeiros, through the course of the 3 years here. As I mentioned earlier, that things are kind of out of order a little bit, which doesn't matter. As long as we cover the material, we should be fine. So one of the things we're going to be covering is we do a unit on structures. We talk about what is a structure, how it's designed, and then why certain structures fail. I mentioned to the students, knowing this kind of thing helps you to build a strong structure. If you know it can actually knock a structure down, you're going to be able to make that structure stronger. So we cover certain terms like live loads, dead loads, so forth. This way they know what kind of forces are put on structures, and then they can make a structure stronger. Once we kind of learn some terms, we're going to start going into designing or sketching our bridges. We chose a bridge. I explained to them that there's plenty of structures, but we're going to design a bridge. So they start with their sketches. We're going to be using balsa wood. Balsa wood is a great product to use. It's easy to cut, glue, pin, so forth, and considering how light it is, it's fairly strong. So they will be building a bridge made out of balsa wood, which they end up getting to take home. These bridges will usually hold anywhere between 50 and 100 pounds when we put them on the bridge tester, so they are pretty strong too. So here's some shots in the classroom of kids designing. They're still in the planning stages, they're drawing. Go through this kind of quick, and here's some of the layouts. These are like the final layouts of students, what they've come up with their designs. That is actually used as a template to start building the bridge. Ultimately, in the end, this is the final product. They will build a bridge. It's probably about 12 inches long and maybe about 7 inches tall. That is the final product. That goes on a bridge tester, and they can see how strong the design they made was. Next thing, a lot of this stuff we covered online with the students last year, and it was perfect for that kind of learning. How to save passwords, get organized in your file folders, Microsoft Office and Google products. They learned, Google Docs, Sheets, Slides, Google Slides, and the alternative to that was PowerPoint, Excel, Word, that kind of thing. Graphic design we saved. We'll be doing that this year. I'll be discussing that in a little bit. Right here is some of the examples of graphic design. Once we get into doing graphic design, the students will actually design a t-shirt and they get to take it home. Microsoft, PowerPoint, so forth. We've done a lot of that already last year, so we won't be touching on that too much. They've already been exposed to most of that. Just some shots of the classroom. Coding with the drones. We're going to try to fit this in. We do a lot of coding, but they can actually code, and instead of having a virtual object moving, this drone will actually fly around the room based on how they coded it. Next thing, AutoCAD. AutoCAD is a technical drawing program. We use it in our manufacturing unit. We show students how something is manufactured from beginning to end. So designing it, taking it right into the wood shop. For example, they can either build a birdhouse or a storage box. We're going to design it and then show them how the planning stages go right up until they actually go in the wood shop and build it. So we do an introduction to AutoCAD. Excel spreadsheets, again, we've done it already. We're ahead of the game on that. We probably won't be doing much on that. Here's some students working in AutoCAD. We're going to talk about materials you find in nature as opposed to man-made materials. We're going to talk about primary processes and also secondary processes. We're going to go over the steps in the manufacturing process, how we use computers to design things as opposed to before. Things were just manually sketched on paper with a pencil. Very important too, we have to talk about shop safety. That's done everywhere. They even have an online user agreement that they mention they're going to be very careful, respect the tools, safety, everything. Here's just some shots of kids taking some wood and doing what they do with it.